Today we will discuss about escape velocity. Escape velocity is defined as the minimum velocity required for an object to escape from the Earth's gravitational field or from the gravitational field of a massive object. Here we will determine the equation for escape velocity. According to law of conservation of energy, the sum of initial energy will be equal to the sum of final energy. Here the K and Ug are the terms for initial kinetic and potential energy, where the K and Ug again are the terms for the final kinetic and potential energy. Let's suppose we pick an object to an infinite location outside the Earth's gravitational field and assume that the object is at rest at that infinite position. At that point, the kinetic energy of the object will become zero and the potential energy of the object at that point will be equal to zero, because the Earth's gravitational field will no longer affect that object. This is the term for the absolute potential energy and this is the term for kinetic energy. The final kinetic energy and absolute potential energy will become equal to zero. This part of the equation will shift to this side of the equation, and 1 over 2 mv square will become equal to gmem by r. Solving this equation for v, which will be the escape velocity, v will be equal to under root 2 gme by r. According to gravitational force, we know that the gravitational force Fg is equal to gmem by r square, where g is the gravitational constant, me is the mass of Earth, m is the mass of object, and r square is the distance between those two objects. Here, force is also defined as weight of object, which is mg. This m will cancel out with this small m, and the remaining terms are gme equal to r square g. This gme will become equal to gr square. Putting the value of gme in equation b, we will get escape velocity as under root 2 GRE. Now, solving this equation for escape velocity of Earth, we know the gravitational acceleration or g of Earth is 9.8 meter per second square, where the radius of Earth is 63,71,000 meter. Putting the values of g and re in this equation, we will get v escape is equal to whole under root 2 multiplied by 9.8, which is the value of g, and multiplied by 63,71,000, which is the radius of Earth. Finally, we will get v escape is equal to 11,174.6 meter per second, which is the escape velocity for an object from Earth's gravitational field, which means if an object is thrown with a speed of 11,174.6 meter per second, it will escape from the Earth's gravitational field. In terms of kilometer per second, the v escape is 11.1746 kilometer per second. Thank you for watching. Don't forget to subscribe and comment your questions.